Hi Algebra 2 students, this is Ms. Penn. This video is on solving rational equations, and some of this is going to look familiar from Algebra 1, but other parts of it will be new. The first thing that I'm going to talk about is something new, and that is that when you're given a rational equation, which means like there are fractions with variables potentially in the denominator, it's very important that we make sure that the denominator is never 0, because we cannot divide by 0 ever in math. That's something that we just never divide. We cannot divide by 0. We would say that's undefined. So the first thing we're going to do is figure out what values of x would make the denominator equal to 0 and make sure we exclude those from the beginning. So I'm going to say we're going to exclude values of x that make the denominator 0. That make the denominator equal to 0. So the easiest way to think about that is to set each denominator equal to 0 and think about what x would have to be. So for example, with the x plus 1, if I set that equal to 0, then move the 1 over to the other side, then I get x equals -1. And if I were to plug in -1 here, this would make the denominator 0. So then I want to say x cannot equal -1 because that's a value I would like to exclude from being a solution. And I'm going to do the same thing with 4x plus 5. So if I set that equal to 0 and solve for x, I subtracted 5 over, and then I'm going to divide by 4. So I get x equals -4/5. And again, that's I'm going to put a line through the equal sign because these are two values of x that should be excluded. Those are not my solutions, but when I get my solution, I want to make sure it's not one of these two things, because if it is, it can't be a solution. Okay, sometimes you get one of those values and it's called an extraneous solution. Okay, so now that we kind of have dealt with that, let's think about how would we actually solve this problem. So the idea here is this is one where if you have a rational on either side and just with one fraction on each side, then we can actually do something you're familiar with, which is cross multiply. So when I cross multiply here, I do the 3 times 4x plus 5, and I do 9 times x plus 1. And I have to remember to distribute there, so 3 times 4x plus 5 is equal to 9 times x plus 1. Distributing in, I get 12x plus 15 is equal to 9x plus 9. Then I can just solve this like a regular equation. So I'm going to move the x's over to one side, so I'll subtract 9x over. And I get 3x plus 15 is equal to 9. Now I'm going to subtract the 15. And I get 3x equals -6. Divide by 3, and I get x equals -2. Okay, so that is my actual solution. I want to cross-check it against what x can definitely not be, and it's not the same, so I'm good. The last thing I can do is just check to make sure. So when I do my check here, I'm just plugging -2 in for the x in the original equation. And I get 3 over -1. Which is -3 on the left. And on the right, I get 9 over -8 plus 5, that's -3, and that is also -3. So it checks out. All right, so we know that the solution here is -2. Now we're going to do an example where we cannot cross multiply, so we have to use another strategy. So example 2 is 1 minus 8 over x minus 5 is equal to 3 over x. So I cannot cross multiply here because I have this 1 minus out front. I can only cross multiply if that was just a fraction equal to another fraction. So I can't use cross multiplication here. Before I begin, I still want to identify what values of x make my denominators 0. So on the right, if your denominator is just x, that means that x itself cannot equal 0, right? Because if I plug in a 0 here, my denominator would be 0. For the x minus 5 one, if I set that equal to 0, then I get x equals +5. So that means x cannot equal +5. So those are the two values I'm going to exclude. Now I'm going to think about how to solve this. So what we're going to do is we're going to multiply the entire equation by the least common denominator. And that's going to allow us to get rid of both of our two current denominators. So we are going to multiply by the least common denominator. I'm just writing LCD. And in this case, our least common denominator should be what's the denominator that kind of encompasses all of our denominators. So the x plus, we need the x minus 5 and the x. So it would be x times x minus 5. Okay, that is what I'm going to multiply this entire equation by, all three parts. So I'm going to kind of squeeze that in over here. So x times x minus 5. And then I'm going to show some more work. So the idea is I'm taking that and it's going to get distributed in to all three parts. So now I'm going to try to write that out and see what we get and see what happens. So I'm doing 1 times the x and the x minus 5. That 1 we don't even really need. So I'm just going to leave it. So that's multiplied by the 1. And then we have minus, I'm going to do my x and x minus 5 again, but then I'm writing 8 over x minus 5. And that's equal to my x and my x minus 5 times 3 over x. Okay, so to kind of take a step back, what just happened? We distributed in the least common denominator. We wrote it next to each of our terms. Now, you may not need to do this every single time once you kind of see the pattern of what we're doing. But the idea here is that it should, when multiplying by the least common denominator, it should always cancel out with the denominator we already have in each term. So like in this one, well, there was no denominator with that 1, so we don't have to worry about anything. But here, the denominator was x minus 5. Now there's an x minus 5 on top that cancels it with the x minus 5 on the bottom. Similarly over here, there's an x on top, which cancels with the x on the bottom. Okay, so by multiplying by the least common denominator, it allows us to lose all of our denominators. It cancels out all of our denominators, and we're left with something easier to work with. So here, what are we left with? We're left with that original, this first x times x minus 5. Then I have a negative, there's an x here and an 8. So I'm just going to write that as 8x is equal to, over here, well, I canceled out those x's, so I have a 3 and an x minus 5. And I'm just switching the order so it looks more familiar to you guys. Okay, so now I'm not done, but this is now an equation that is a lot easier for me to solve. I know what to do now. I can just distribute and then go from there, right? So let's start by distributing. I'm going to distribute the x in there and the 3 in over here. So I get x squared minus 5x minus 8x is equal to 3x minus 15, okay? And now I notice I have something that has a quadratic, right? So you won't always get a quadratic term, but sometimes you will. And the key here is that that means that I need to think about how do I solve using quadratics. Well, one thing that I know how to do is I could move everything over to one side and combine my like terms and then see if I can factor or use quadratic formula. So I'm going to try that. So to get everything kind of like combining my like terms, well, I know I have this 5x, negative 5x, negative 8x, and then I can also move over that 3x, right? So those are all going to combine to give me x squared minus 16x is equal to negative 15, and then I could also move that negative 15 over by adding. So then I have x squared minus 16x plus 15 is equal to 0. Now that looks like something that might factor actually, so like what multiplies to 15 and adds to negative 16, negative 1 and negative 15. So I have x minus 1, x minus 15 is equal to 0. Setting each of those equal to 0, I get x equals 1 and x equals 15. And I just want to double check, are 1 and 15, are either of those values that we wanted to exclude at the beginning? No. So I'm good, right? And again, you always do want to check your work. For the sake of time, I'm not going to show checking your work for this one, but the idea is you could plug 1 back in and then separately plug in 15, and both should make our equation true. Okay, so now we're going to do one example where there is a extraneous solution, which means that one of our solutions cannot actually be a solution. So example 3 is going to be 6 over x minus 3 is equal to 8x squared over x squared minus 9 minus 4x over x plus 3. So first step is to identify what values of x should I exclude. So I see an x minus 3 is one of my denominators. So if I set that equal to 0, that means x cannot equal positive 3. X squared minus 9, I'm already thinking about the fact that that factors into x minus 3, x plus 3. So then what values of x could this not equal? Well, the same one I had here can equal positive 3, but then it could also can equal negative 3 from the second factor. And that's the same one I get here, right? So we get these two values. Okay, so x can't equal positive 3, x can't equal negative 3, but maybe it ends up equaling something else when I go to solve. So now, approaching solving this, I'm going to use the same strategy I used in example 2, where I identified the least common denominator and multiplied the whole equation by it to get rid of all of my denominators. So here, the least common denominator, can you tell what it is? So we have an x minus 3 here, an x plus 3 here, and then here we have both of those two things. So what is the common denominator that covers all of them? It's going to be the combo, the x minus 3 and x plus 3. So that is what I'm going to end up multiplying my entire equation by up here. So the idea is I'm taking this whole equation and I'm going to distribute in an x minus 3 and an x plus 3 to each term. So that's what I'm kind of showing up here, so we can kind of imagine it gets multiplied into each part and what happens. So when it gets multiplied into the first one, and again, like as you get better at this, you might not need to show this step. You might do this step in your head, but there's going to be something that cancels there. Is equal to, then I'm going to just quickly write it out, x minus 3, x plus 3. And then this is 8x squared over, well, I'm going to write that in the factored form, might as well, because it'll be easier to see what cancels. Minus x minus 3, x plus 3. And then I have my 4x over x plus 3. Okay, so again, you don't have to do this step every single time. You might see what happens without writing it all out. But now let's see what cancels. So in the first term, that x minus 3 is going to cancel. So I'm left with a 6 and an x plus 3. Over here, the entire thing cancels, right? Same thing on top and bottom. Isn't that satisfying? So then I'm left with an 8x squared. And then in the last part, I have an x plus 3 and an x plus 3 canceling. So I'm left with minus 4x and then x minus 3. Okay, so now that we have, we're not done, but it's a lot simpler than it was, right? Now we just have what looks like some sort of quadratic equation that I can try to get everything over to one side and then try to factor. Okay, so I have some distributing to do first. I'm going to kind of do this quickly. So we get 6x plus 18 is equal to 8x squared minus 4x squared plus 12x, because this is negative times negative. Now I'm going to move everything over to one side. So I'm going to subtract 6x over, and I'm going to subtract 18. I'm just doing that all at once just to save myself a little bit of time. So I get 0 equals, I'm going to combine 8x squared minus 4x squared is 4x squared plus 6x minus 18. And now I'm thinking about, okay, so can this factor? Well, the first thing I notice is that there is a GCF I could take out of 2. So then it becomes 2x squared plus 3x minus 9. And then I would try to think about I need to think about what multiplies to a times c. So that's negative 9 times 2, negative 18, and adds to be 3. So that would be 6 and negative 3. And then I'm going to do this by grouping. I'm actually going to divide, I'm going to pretend like I just divided both sides of this equation by 2 to kind of ignore that 2. And then I have, okay, 2x squared, that 2 out front, I'm saying, I divided over. Plus, so I'm going to split this and say plus 6x minus 3x minus 9. And now I'm going to factor this by grouping. So from the first 2, I'm pulling out a 2x. And from the second, I'm just going to pull out a negative 3. And then what's left over is x plus 3 here and x plus 3 here. So we get 2x minus 3 as one factor and x plus 3 as the other factor. And then we're almost done. I just need to set each factor equal to 0 to solve. So I get 2x minus 3 equals 0, x plus 3 equals 0. So here I get 2x equals 3, and then x equals 3 over 2. And here I get x equals negative 3. All right, so this one is definitely a solution. But this one, if you notice, if we go all the way back up to the beginning, we said x couldn't equal negative 3. So that means that this then becomes what's called an extraneous solution. Extraneous solution. So basically, it looks like it's a solution based on the algebra we did, but the algebra we did assumed that none of these values would make the denominator equal to 0, right? So we really can't include this as a solution. So we will be practicing this more in class tomorrow. Bye, guys.